Hi, today we're going to do another variant Sudoku. This one, I don't know what to expect too much. It has unique rules. I don't usually, I'm less interested in these Sudoku puzzles that have these gimmicky type rules. But, this one, it's fairly simple to understand. And the grid is very clean. So, obviously, there's not going to be a lot we're going to be doing in the grid right away. I think the first thing we're going to have to do is decipher the rules. Now, as usual, the quad rules are standard rules. So each of these circles is intended to come with 4 small digits inscribed in them, which indicate the 4 digits that surround the circle in some order, possibly with duplicates. But what those 4 digits are is constrained by our second rule, the quadratics rule. So of the 4 digits on a circle, 2 of them are the 2 solutions, the x squared minus ax plus b equals 0, where a and b are the other 2 digits on that circle. If the equation has only one solution, that digit is repeated twice. So let's call, I need some new variables, c and d. Let's call c and d the 2 solutions to the quadratic equation, possibly c equals d, possibly c does not equal d. Then, of course, a is equal to c plus d, and b is equal to c times d. So this is just a complicated way of saying there are 4 digits on each circle, c, d, c plus d, and c times d, where c and d could be anything. Okay, so what can c, anything, no, they can't be 9 and 8 because good luck making 17 in a single digit. Their product is at most 9, which means c and d can never have, it could have 5 if it could be 1, 5. Yeah, okay, suppose there's a 1 on the circle. So we have 1, d, d, and 1 plus d, which is possible for these circles which straddle more than one box. It could have a repeated digit. So such 4 cells are capable of having a 1 on them. If you have a quad that is interior to a box, it cannot have a 1 because you can't have repeated digits. Which in particular implies one of these is a 1, and one of these is a 1, one of these is a 1, one of these is a 1. I suspect that is important. Can you have 2 1s? 1, 1, 1, 2. No, you can't have 2 1s. So we have 2 1s here, but they are not both in this box. Okay, so it could be 1d, d, d plus 1. What if there's no 1 in the circle? We can't have a 5 because then you'd have at least 2, 5, 7, 10. So you can have 2, 2, 2, 3, 2, 4, 3, 3, 3, 4, and 4, 4. Well, 4, 4, no, that's 16. 3, 4, no, that's 12. So that leaves, I'm going to be a bit more explicit and enumerate all of our possibilities. So allowing repeats, we can have 1, 2, 2, okay, 1, 2, 2, 3, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, and 1, 8. Going with 8, 9, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. So each of these pairs is a quad. I've put them in separate digits because I have a duplicate, separate cells because there's duplicates. Now, if I don't have a 1, I can have 2, 2, along with 4, 4. So 2 plus 2 is 4, and 2 times 2 is 4. I can have 2, 3 with 5, 6. I can have 2, 4 with 6, 8. I can have 3, 3 with 6 and 9. And 3, 4 is impossible because their product is 12. So these are the 4 ways of doing that. Every single cell, and I think I'm going to take the initiative of coloring them, that is interior to a box, has no repeated digits, and it is either 2, 3, 5, 6, or 2, 4, 6, 8. In either case, it has a 2 and a 6. So each of these blue ones has a 2 and a 6, which implies we have a 2, 6 here, a 2, 6 here, and that's all that implies. I think enumerating all of the ways of having a 1 with any of the digits from 2 to 8 is not very helpful. But I do want to retain these enumerations. So I'm going to sneak them into the lower left corner where I suspect they will be the least obtrusive. So I can have 2, 4 with, so 2, 4, 2, 4. I can have 2, 3, 5, 6. I can have 2, 4, 6, 8. And I can have 3, 3, 6, 9. Okay. Each of these. So these 3 digits are taken from 2, 3, 4, 5, 6, and 8. It could be 2, 2, 4, 4. What do we know about a quad that has neither 2 nor 6 on it, such as this one? We know it has a 1 because every single one of these has a 2 or 6 on it. We know it has a 1. The 1 cannot be paired with 2, the 1 cannot be paired with 6, and the 1 cannot be paired with 5. So the 1 can be paired with 3, 4, 7, or 8. We do know these are different quads from each other. These are the same quads as each other. This could be 1, 2, 2, 3. That's perfectly possible. Okay, the thing that the 1 is paired with is duplicated in this quad. So it appears in both of these boxes, so it can appear in neither of these quads. So the 1 cannot be paired with 2, 3, 4, 5, 6, or 8. It must be paired with 7, right? 2, 3, 4, 5, 6, and 8. So this is 1, 7, 8, and there's 2 7s, which I'll indicate by having a corner mark to especially highlight that fact. So there's a 7 up here. The only way a 7 can appear is if it's with a 1, and we know these don't have a 1. So one of these has an 8, and the other of these has a 2, 4, 6, 8. The 8 appears with a 7 and a 2, 3, 5, 6. 8, 7, 2, 3, 5, 6, leaving 1, 4, 9 in some order, either here or here. What did I say? 1, 4, 9? Because this is 7, 8, and this is 2, 3, 5, 6, either here or in this box. 1, 4, 9. Is there a problem with this being 1, 4, 9? I don't see it. Seems perfectly fine. Hmm. Three, 3, 6, 9 is a very restricted thing to fit into the grid, but not so restricted that I'm able to easily eliminate it anywhere. Oh, of course. We know here's a 2, 6, here's a 2, 6, that implies, and here's a 2, 6, and we know they can't be here. So, this is a 2, 6 pair. That does mean this can't be 2, 4, 2, 4, for whatever that's worth. 2, 6, and then this is either 3, 5 or 4, 8. If it is 3, 5, then we know one of these is 3, 5, 2, 6, and the other is 2, 6, 4, 8. Yeah, I guess what I'm saying is that these 6 digits are 2, 3, 5, 6, and 8. And then this is 9. We have a digit. This set contains 2, 6 twice. Like these 4 digits must equal these 4 digits, right? Because these 2 digits are somewhere up here, and then obviously 2, 6 is as well. So if this is 3, 5, then we have 3, 5 here, and then 3, 5 here, or vice versa. If it's 4, 8, We have 4, 8 here, and then 8, and then 4. If this is 4, 8, one of these must be 3, 5, because these are not both 3, 5. Can this be 8? I think no. 8 can only appear on 2, 4, 6, 8. I guess this could be no, okay. If this is a 2, 6 something, the 2, 6 goes here, and we have an impossibility because this needs to be horizontals, not verticals. So this is not a 2, 6 something. It is not a 2, 4, 2, 4 because neither of these is a 2. It's not a 2, 3, 5, 6. It's not a 2, 4, 6, 8. And can it be 3, 6, 9? This would be a 9, impossible. Therefore, it has a 1. A 1 with an 8 in the same thing means that the other is either 7 or 9, both impossible. A 1 with a 5 goes with a... Well, this digit must equal that digit. Right? Because on the 1 there are 2 digits that are equal, and it's not this and one of the others. So this equals that. And specifically that makes this 2, 6, 2, 6. 3, 4, 5, 8. 3, 4, 5, 8. And specifically it pairs with the 3, 4, 5. So 1 times blah is blah, and 1 plus blah is blah, making this 6. And this a 5. And the 5 goes with a 3. So this cannot be an 8. Making this an 8. 1, 7, 7. It looks believable. What are our remaining digits? 1, 4, and 9. And here we have 3, and 5, and 9. Right? Where can 3, 5 in this grid go? They must go here. That makes this a 9. This means this is a 4. This is 7, 8. And 4. Okay, healthy progress. Feels a little slow for us to have gotten this far, but what's she gonna do? That's 1 because of this, of course. This could have a 5. Probably does. But I think this is where we next concentrate our attention. It's probably something like... No, it can't have 2 3s because both 3s would go there. It's obviously not 2, 4, 2, 4. Can I have a 2 and a 6? This cannot be 6. Could be 2. In fact, one of those is a 2 and one of those is a 6. And then it could be like 3, 5. Ah, no, it can't be 3, 5 because then this would be 2, 6, 3, 5 in 4 digits. So this is a 4, 8. Meaning one of these is a 7, obviously. 4, 7, 8. Yep, that checks out. Do I know the identity of this one? It has a 2-6 as usual. I see no obstacle with 3-5 or 4-8, so either way seems very believable. And either if it's 4-8, there's a 4-8 here, but that's fine. 4-8 to and a 2 or 6, but not 2 and 6. So I think we're back to assessing this quad. And we just said it can't be 3-3-6-9. It can't be 2-4-2-4. And neither of these has a 1 or 9 on it. So this definitely has a 1, and that 1 must be there. So these two digits must be the same, namely 2. Right? Because 2, 2, 3. Okay, which informs this is not 2, 3, 5, 6. It is 2, 4, 6, 8. No 6, no 4. Here we have a 4 and 8, and either a 2 or a 6, but not both. So here's the 5, and here's the 9, 7. I already see where this is going. Just double checking I didn't miss a digit. 1, 2, 3, 4, 5, 6, 7, 8. Yes, okay. And the only way to have a 9 is with 3, 3, 6, 9, which would require both of these being 3, when clearly neither are. Or with 1, 8, 8, 9. Oh, and there's no 2 there, obviously. Five, 7, 8. I'll worry about the lower left, lower right later. 4, 8, 6. It's going smoothly finally. 9, 1, 2, 3, 4, 5. 6, 7, 8, 9. This sees everything. It sees 1, 2, 3, 4, 5, 6, 7, 8. It is a 9. I don't really want to do this quad, but I don't see a more logical stop. Next stop. Excuse me. 1, 3, 3. Okay. It probably has a 1, but let's entertain for the moment the possibility it doesn't. It's not 2, 4, 2, 4. It's not 2, 3, 5, 6. Why not? 3, 5, 6. Oh, this is okay. This can be neither 2 nor 6, so it can't have 2 of 2 and 6 on it. Can it be 3, 3, 6, 9? Signs point towards no, because this can be neither 3 nor 6 nor 9. Okay, so this has a 1 on it, and the 1 must be up here. And then the 1 goes with 3, 3, no. 5, 5, maybe. 5, 5, maybe. 7, 7, no. So 1, 5, 5, and then 6. And then this is 2, and why do I not see it? 8, no. 6, no. 4, 3, 1. Okay. Something felt suspect about that reasoning, but it's surely fine. 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 2s are down here, so one of these is a 2. And we might soon have to clear out the pencil marks in the lower left, but not quite yet. If this is 1, we have 6, 6, 7. So it's not a 1. Two 6 could go with 3, 5, or 4, 8. And that's it, right? It has no 1 on it. It's not 2, 4, 2, 4. It's not 3, 3, 6, 9. So it's either 3, 5, or 4, 8. This has no 1 on it. I would like it to be 2, 4, 2, 4. It has no 6 on it, so it is 2, 4, 2, 4. And then 4 goes with 8. I believe that's every single quad. So, oh, well, of course I think I wanted some of the stuff I just deleted, but that's fine. It's no great loss. 3, 7, 9. I said there's a 1 here, and I think we've restored ourselves. 1, 2, and 3 can only go there. 1, 2, 3, 4, 5, and 8. No, 7, 6. 6. It's always 6. 7. The 4 is disambiguated. Obviously, I should know this digit. It is a 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do feel like I am taking a slightly leisurely attitude to finishing this, but yeah, it's fine. 1, 2, 3, 4, 5, 5. 5 goes here, 6, somewhere here, 7 on the left, 8, and 9. 7, 8 in the middle, disambiguated. Means this is no 7. 3, 4, 4, 9, still ambiguous. 3, 5, 7, still ambiguous. 3, 7, 3, 5, 3, 4, 4, 5, 1. 2, 6 is cleared in the top. Am I really going to get everything from that? Why is this not a 6? Okay, why is this? One of these is a 6. I don't know which. To go with that. Ooh. Don't tell me we have a Y wing or similar. Surely not. I think it's hard to do that. Or a bint triple, or whatever they're called, with only 3 boxes available, since obviously this 1, 9 is not resolving anything. Let's just double check we haven't missed something here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's gonna be Y-wing, right? No better time to learn how to do those than now. 3, 4, 4, 6, 3, 5, 1, 5, 1, 6, 6, 4, 3, 5. Yes, okay, that's just a loop. I'm looking in rows if you're wondering. 5, 7, 5, 9, 9. Yep. I haven't made an error. These are all correct. 2 plus 4 is 6. 2 times 4 is 8. 1 plus 5. 2, 4, 6, 8. 2, 4, 6, 8. Who do we differentiate? 2, 3, 5, 6. 1, 2, 2, 3. 1, 7, 7. 8, 1, 8, 8, 9. 1, 5, 5, 6. All the quads are correct. Or consistent with the rules, anyhow. 3, 5, 7 works with the column. 4, 6 works with the column. 3, 4, 9 works with the column. 1, 9 works with the row. 7, 9. 1, 6. 1, 5. 6, 7, 9. 5, 9. Yes, okay. All the information that's in the grid is consistent so far. So probably correct. Which means we are down to one of those weird Sudoku rules I never learned. I suspect the one cell with 3 possibilities, that one of those can be eliminated. If this is a 7, this is a 7, and we have 9, 3, 5, 3, 4, 6, 4, 9, 5. That seems impossible. If this is a 7, this is a 7, this is a 5. If this is a 7, 7, 9, 3, 4, 9, 5, and 5. Well, okay, this isn't a 7. I don't feel like I got the most out of that, but if it works, it works. All right. Other than a little hiccup at the end, fine solve.